Hello, welcome to the Test Suite Analysis Workshop. So the main idea of this workshop, it's going to be a short one, is to be able to run a test suite and be able to automatically assess properties of that test run in terms of how fast did the test run, um, did they pass or fail, and then being able to use those statistics to measure things like effectiveness and quality of the test suite, even doing things like detecting flaky tests. And so if when you get started, what you're going to want to do is import or clone the workshop. And if you don't have a local environment with Java or Node.js already, then there's a virtual machine that you can work in, which is what I'll be doing. And I'll start off with a simple code tour. So there is in this repository a simple Java project called Simple Calc, and it's just a really dumb Java-based calculator for doing simple addition, etc. And you'll see that if you look in the test directory, there's a test suite that has a collection of JUnit tests like this one here, where it's just running a simple calculation and making assertions. So nothing special, but it really is enough for us to do that what we need to. Because our main goal isn't so much about writing tests, it's about can we analyze an existing test suite and its results. And so that's actually this next part, which is more interesting, is being able to run Maven test and then looking at the results of that test suite run. And what you'll see is when you run that, there will be inside the target Surefile reports, which is the plugin that is being used to generate these, is a XML file that will have a list of test cases. And you can see this will be the class that the test case was, the name of the test that was run, and how long it took. And then if it failed, there will be a failure node that will say what the message was and the type of failure, and then a stack trace for it. And so all this information will be useful for being able to further analyze the test suite. So to help do this in the workshop, there's some Node.js code that will basically automate that process of running Maven test. So you'll see code that looks something like this, where it's just using a child process to run Maven. And then when it's done running, it will get the test report, which is basically looking for an XML file in that directory. And then it will translate that XML report into JSON, basically, because messing with the XML itself is kind of messy. So you'll see basically if you run this, you'll see a printout of all the test runs that will look something like this. All right, so let's go ahead and poke around a little bit. So remember, I'm going to have to go into my VM. That's going to be all mounted in Baker X. So it's the same workshop materials right there. And the first thing I'm going to do is I'm going to go into Simple Calc and poke around like you saw, right? So you see the POM file for Maven. You see the code like source, test, and this long path to where you see where the test suite is. And let me just go ahead and run Maven test. And you see that this, if you run this the first time, there's going to be this big long thing of where it's downloading all these dependencies. So I've already done that. So it's moving on to running the test. And there are about 6 tests in this one. And one of them fails just because it just happens to be failing. And the others pass. And then there's one that's flaky that will occasionally fail. So right now we see that we ran all 6 tests and we got that one failure that I was talking about, which is fine. That's the expected result. So what we want to do now is we're going to pop back out. And if you haven't run npm install already in this directory, you want to go ahead and do that. And then we're going to run our simple driver code. which is basically doing our simple priority analysis. So this is just, again, doing what we did before. It's running Maven test, so that's going to take a second. But what you'll see that's a little bit different is that eventually it's going to print out all the results in this convenient format where it basically has the name of the test and the time that ran, that it took to ran, and whether it passed or failed, right? And so you see the same results up here. Okay, so that's pretty cool. And what we're gonna do for the workshop is fairly simple. What I want you to do is to extend this code, just so you have a chance to kind of play around with the idea of it, is to use the fact that there are different execution times and different statuses to sort that list, right? So this is just a list of tests. And we're going to be using this idea of, imagine that you had all sorts of statistics about how often a test was passing and how fast that it ran. Then you can imagine one thing that you might want to do is run the faster test first, right? So if they're going to run faster and it doesn't take 10 minutes to run, why not do those? And especially if they say historically have failed in the past, or they historically have revealed faults, right? Real faults. That would be the ideal thing to run, is basically all the ones that typically fail and do it fast, right? Like that would be perfect to making a fast CI build or a useful pipeline. So that's not quite what we're doing here because we don't have a lot of historical data, but just to simulate that idea, what we're just going to be doing is just take this list here and then reprint it out in an ordered way. So if I jump into my code here, it's going to be basically here. And what I'm going to do is, instead of printing it out like this, I'm basically going to test sort and then pass in a comparator function where it's going to be comparing the test. And then you're going to have fun remembering how is it that I sort all these things. And so it should be that you're basically going to have a time property and a status property. And you can compare that to whether it passed or failed and relate that to the other tests, right? So let's just try something real quick just to see what it might look like. So let's say if I just sort based on time and see what that looks like. So I'm going to return, and then I'm going to print this. Okay, so it's going to have to rerun the test. That's kind of the downside of the way this is set up. So that will take a sec. If you were feeling, if you wanted to kind of take a shortcut and you thought that was taking too long, you could, because the XML file still exists there, you could just sort of comment out this part of the code, and then you would have to comment that out. And you could just run the part where it just read the results and printed out stuff. All right, so let's see what I did. So I sort of got this backwards, but it gives you the idea. I ended up printing out the ones that took the longest, right? So this one was the longest one, this was et cetera, right? And then this is the shortest one. That one's really fast. So see if you could extend this to take into account both the time and prioritizing failures first, and go from there. And that one's just kind of a warm up, because where the more interesting thing that we're going to do next is detecting whether there's any flaky test, right? And so a flaky test is essentially something that is inconsistent, something that will fail sometimes and then pass other times, and it isn't producing a consistent result. But how is it that you would actually calculate that flaky score? So to help think about this, I have a little table here where it has 4 test cases, and we've run them 4 times. And the expected behavior of the test cases is also provided. So it's expected that this would pass, this would fail, this would pass, this would fail. And what is actually happening is for test A, for all 4 times, it's actually passed. So they all passed. That's good. That's what you would want to happen. And likewise for test B, it's all failed each time. But here are something a little bit weird happening here. So for test C, it is passing 2 of the times, but then in 2 of the other runs, it failed. Okay, so this is now exhibiting flaky behavior. And likewise, for test D, we're expecting this to fail, and it did for 3 of the times, but for 1 of the times, it happened to pass, right? So this is also flaky. And so what I'm going to want you to do is to use the quiz here to kind of think about how would you calculate the flakiness scores for each one of these, as well as failure rates, flakiness scores. And then finally think about what would be the right formula for calculating this score. And then once you have that working, what you're going to want to do is implement the flaky test analysis. And the way that's going to work is you go down to this code here where you see the calculate flaky test. And we're going to just do the same thing, except that we're doing this in a for loop. So you see how we're doing this for X number of times, and we're running this over and over and getting the results. So you're going to want to store in some sort of data structure the passing and failing rate of each test. Maybe a dictionary might work for you. And then what you're going to do is calculate the flakiness score for each test at the end of it using the formula that you found to represent that. And so that's not too difficult. I would suggest modifying when you're first starting out to use something real simple so that you're not waiting, a really long time for all those tests to run while you're getting your logic to work. And then once it seems like your stuff is working okay, I would bump up this number so that you can get a more accurate. Because remember, the more times you run it, the more effective you are at revealing flaky test. So that's how I would approach this workshop. And like I said, this is fairly short, but it's going to be essential for your second milestone. So having this code will be really useful for understanding how to do your milestone 2. All right, good luck.